Welcome back. This is day 6. I'm Adhiraj and you're in the openclaw bootcamp. Let me ask you something. When was the last time your agent did something useful without you asking it to? The answer is never, because up until now, it can't. You open up Telegram, you send a message, you get a response, and that's it. Close the app and then nothing's going to happen. Your agent just waits. Today, we're going to fix that. You're going to write a single file called the heartbeat markdown file, and it's going to teach your agent to act on its own, on a schedule, proactively, whether you're around or not. Tomorrow morning, you'll wake up to a briefing that you never requested. Let's build it. Let's start out with the mental model like we always do. So first off, reactive versus proactive and why that distinction matters architecturally. Then the heartbeat loop itself, how the tick cycle works, and where the heartbeat markdown file fits inside it. Then the anatomy of the file. So what to write, what not to write, and the built-in silence mechanism that keeps your phone from buzzing every 30 minutes. After that, we cover the 4 real examples. Morning briefing, a task queue monitor, system monitoring, and a daily research summary. We look at the time-aware instructions and how to write conditions that the agent actually understands. Then cost and safety, because a badly written file can get expensive fast. And finally, debugging, so how to read the heartbeat log and fix a setup that isn't firing. All right, so 3 concrete outcomes by the end of today. First, a working heartbeat markdown file that sends you a morning briefing automatically. It shouldn't be configured or waiting. It should actually just be sending it to you. And you're going to test it before you go to sleep tonight. Second off, a clear mental model of the loop. So the tick interval, file read, task execution, and channel delivery. You should be able to draw this on a whiteboard by the end of today. And third, a super lean file. So under 25 lines, so that doesn't burn tokens every tick. Leanness here isn't a stylistic preference, but it's cost and a reliability decision. All right, quick check on where we came from. So on day 5, you connected the channels. Telegram is secured with your numeric user ID in the allow list. At least 1 second channel is live and tested, whether that's Discord, WhatsApp, iMessage, or Slack. You verified that the cross-channel memory works, so something told the agent on Telegram shows up in web chat, and then you send a voice note and confirmed the transcription-based response. And here's why day 5 directly unlocks today, day 6. Your channels are the delivery mechanism for everything this heartbeat markdown file is going to trigger. When your agent sends a morning briefing, it's going to go through Telegram. When it fires an alert, it's going to route through whatever channel that you configure. Day 5 built the pipes. Day 6 is just what flows through. Before we touch any configuration, I want to make this mental model super crisp. It's literally the thing that's going to make everything else click. Days 1 through 5, your agent was reactive. So every interaction followed the same pattern. You initiate and your agent responds. You send a message, it replies. Nothing happens without you. And so the agent is always waiting. Day 6 changes that flow completely. So the gateway runs on a timer. Every 30 minutes or 60 seconds, this is whatever interval you set, then the tick will fire. On each tick, the gateway loads the heartbeat markdown file, hands it to the agent as the task context, and the agent decides what to do. If there's something to report, it sends it through your channels, and if there's nothing, it's just going to stay silent. So you're not involved, and you don't ever have to ask it when you do this. That's the difference between a chatbot and an autonomous agent. It's not a technical one, but it's an architectural one. It all comes down to this one file. Now let's make the loop super concrete with these 4 steps. Step 1, the timer is going to fire. The info is set in your openclaw.json under agents.defaults.heartbeat in the every 30 minutes, 60 minutes, it's whatever you chose on day 4. It's just a clock ticking in the background. Step 2 is the gateway is going to read that heartbeat markdown file. It's going to load the file from this file path shown on the screen as the agent's task context for this tick. And the default prompt the agent receives is literally read heartbeat markdown file if it exists and follow it strictly. If nothing needs attention, reply heartbeat_OK. That's built in and you don't need to write it yourself. Step 3 is the agent's going to decide and act. So it evaluates the conditions in the file, calls tools if needed like web search or memory read or shell commands, composes a message if there's something to say, and then packages a response. Step 4, it's going to deliver through a channel. So if the agent decided to say something, it's going to route through whichever channel you specified in the target config. If it decided there's nothing to report, it's just going to reply with heartbeat OK, and the gateway strips that and drops it silently. There's no message sent and no notification reaches your phone. Now there's the cost side of things. So you must set the model key in the heartbeat config to a cheap model like Haiku or GPT-4o Mini. Without an explicit override, the heartbeat uses your default agent model, which could be expensive. You also want to set light context to true and isolated session to true, and these are going to dramatically reduce the token load per tick. Light context keeps only the heartbeat markdown file from the workspace bootstrap files instead of loading everything. Isolated session is going to run each heartbeat in a fresh session with no conversation history. They can take you from 100,000 tokens per tick to 2 to 5,000. All right, now this is the most important distinction to get right before you start writing anything. openclaw.json controls when. The heartbeat block in your config lives in agents.defaults heartbeat. Here's what it looks like, right? So the every field is your interval. So 30 minutes or 60 minutes or 1 hour or 2 hours. The model field is the cheap model you're using. The target field is going to control which channel receives the output. You can set it to last for your last active channel, or a specific channel name like Telegram or WhatsApp, or none to suppress delivery entirely. Then there's 2 critical cost flags: light context true, and then isolated session true, and then ACK max charge at 300. This is how many characters the gateway allows after a heartbeat OK token before it decides to deliver the message anyways. One important thing here, the target defaults to none. That means if you don't explicitly set it, your heartbeat's going to run but send nothing. You need to set target to Telegram or last, or whichever channel you want output delivered to. Don't skip this, or you'll wonder why your briefings never arrive. Also worth knowing here is there's an active hours block that you can add with start, end, and time zone fields. This lets you restrict heartbeat runs to specific hours, say 8 a.m. to midnight, so you're not getting alerts at 3 in the morning. You can also set the time zone to your IANA time zone, like America, New York, so the agent isn't using your server's UTC clock. The heartbeat file controls the what. So the file is in plain English. You can throw bullet points in there, mark down headers, whatever structure works for you. The agents can read it as natural language instructions and decide which actions to take. The heartbeat file has 0 scheduling power on its own. It's just a task list that gets read when the clock fires. A lot of people try to put timing inside their file, writing things like run every day at 8 a.m., and that works as a time condition that the agent evaluates, but the tick interval is always in the config. The heartbeat markdown file is where you write what to do when the interval fires, including the time conditions the agent can check using the current time. Now let me show you what the file actually looks like. It's going to live at openclaw workspace heartbeat.markdown. It's a markdown file, right? As you probably know already. It's short, it's plain English. You can use headers to group related tasks, bullet points for individual items, and also comments to remind yourself what things to do. One thing the doc support that's worth knowing is you can also use a structured tasks block with per task intervals. That looks like a YAML block at the top, with each task having a name, an interval, and a prompt. When you use this format, openclaw parses the block and only includes tasks that are actually due on a given tick. If no tasks are due, the heartbeat is skipped entirely, and there's no API call made at all, and that's the most cost-efficient way to run multiple tasks at different frequencies. But for most people starting out, plain English bullet points work perfectly. The agents can read them, evaluate each one, and act accordingly. Now, what belongs in here, right? Time conditions written as plain English, like if it's between 8 a.m. and 8:30. You also channel directives like send to Telegram, references to memory like check memory markdown file, conditional logic written naturally like if a task is overdue. You want to keep it under 20 lines, ideally under 15. Every word in the file costs tokens on every single tick, so bloated files are directly expensive. Now, what doesn't belong here? Scheduling syntax, any kind of cron expression or interval notation is wrong here. That lives in your openclaw.json. Long paragraphs don't belong here. Tasks that require your real-time input do not belong here. And anything that your agent can't do autonomously with the tools you've given it do not belong here. One more thing, if the file is empty or contains only blank lines and headers, openclaw skips the heartbeat run entirely to save API calls. That's intentional, and so an empty heartbeat markdown file means nothing to do and costs you nothing. I want to spend a full slide on this because it's the mechanism that keeps your phone from buzzing 48 times a day. This is how it works under the hood. So the default heartbeat prompt already tells the agent, if nothing needs attention, reply heartbeat OK. You don't need to write this in your file. It's built into the system prompt that the gateway sends with every single tick. When the agent replies with heartbeat OK at the start or end of its response, the gateway strips that token out, and if the remaining content is under your ACK max chars, which defaults to 300 characters, the gateway drops the message entirely. So nothing gets delivered to your channel, and thus the phone stays silent. Now here's what happens without this system. The agent is wired by training to be helpful. When it receives the task context and evaluates the conditions, its default behavior is to produce a response, even if that response is, I checked everything and there's nothing to report. Without this heartbeat OK suppression, your agent would message you every 30 minutes, confirming that nothing happened. And so it's literally 48 minutes a day. Your phone would be buzzing constantly and you turn off your notifications. And then the moment you do that, your agent's alerts become invisible, including the ones that actually matter. Then you've broken your own monitoring system. With the heartbeat OK, the agent only reaches out when it has something real and important to say. The channels stay quiet, and so when a message arrives, you pay attention because you know that it's actual signal. That's the value, and here silence is the feature. You can actually go ahead and reinforce this in your heartbeat markdown file by adding a line at the end. If nothing needs attention, stay completely silent. The system already handles it, but the extra instruction doesn't hurt, and some people find that it makes the agent more reliably quiet. Let's build out the first real example. So the morning briefing is the most common first automation. The structure is a time window condition and a guard to prevent repeats, a content specification, and then a memory write to mark it done. So in terms of the time window, if the current time is between 8 a.m. and 8:30 a.m., you need a single window, not a single point in time, because your heartbeat fires on schedule. If it fires at 8:05 and your condition is 8 a.m., it's going to miss. Now the guard is also critical. It says, and you have not sent your morning briefing today. Without this, every tick in your 30-minute window triggers a new briefing. If your heartbeat is 30 minutes, you could get 2. If it's 15, you get 3. The guard reads that from memory, and the agent checks a flag it's set on the previous run. Content is whatever you want. So date, top tasks from the memory markdown file, calendar, events, weather, just one sentence for each, and the agents can compose this from memory, reads, and tool calls. Then mark briefing as sent in memory so it doesn't repeat this tick. This is the write that sets the guard flag for the next tick. Alternatively, another solution is if you want to use the tasks block format, you can set this as a single task with 24-hour interval and the agent handles the deduplication for you. The timestamp is tracked automatically in the session state, so there's no manual guard needed here. Our second example is going to be monitoring a task queue in your memory for upcoming deadlines. The pattern is essentially you're checking your memory markdown file for tasks marked as pending or to do. If any have a due date within the next 2 hours, you want to send an alert to Telegram with the task name and the time remaining. If the task is overdue, you want to flag it as urgent and message immediately. If there's nothing due soon, you want to stay silent. This is going to run on every tick. It's stateless. The agent's just going to read memory and then make a decision. The cost per tick is low because most of the time nothing is due and the agent stays silent. The reason this is so powerful is that you can add tasks conversationally. You tell your agent on Telegram, add to my task list, review the contract by 3 p.m. tomorrow, and the agent's going to write that to its memory markdown file. And on the next heartbeat tick, the monitor picks it up, starts tracking the deadline. You never configured anything, you just had to talk to the agent. Third example is system monitoring. This one requires the shell tool to be enabled in your agent's tools configuration. Now for the tasks, run a disk space check and alert if any drive is above 85% full, check if the key services are running, and alert immediately if any are down. You want to monitor the CPU load average and warn if it's been above 80% for 2 consecutive ticks. Now, 2 things to calibrate here. First, the heartbeat interval. So system monitoring usually warrants a shorter interval, meaning 15 or 30 minutes. For a morning briefing, you can get away with 60 minutes. But for a server that could go down at any moment, 30 minutes is safer. You want to set the every field in your openclaw.json to match your most time-sensitive task. Or better, use the tasks block in your heartbeat file and give your server checks a 15-minute interval while your briefing stays at 24 hours. Second, a production caveat. So for infrastructure that has real SLAs, you want to use dedicated monitoring tools like Datadog, Prometheus, or Grafana. The heartbeat monitor is excellent for personal projects, home servers, and convenience alerts. For critical production systems, dedicated monitoring is more reliable and much more appropriate. Our fourth example is daily research and news summary. At 7 in the morning, you want to search for top news and whatever topics you track for the past 24 hours, summarize it in 5 bullets, 1 sentence each. Send to Telegram with a header like evening briefing and mark it as sent so it doesn't repeat. These topics are obviously completely up to you. Replace AI and crypto with whatever you need to stay on top of. Competitors, industry news, stock tickers, papers, GitHub releases. The agent can run a web search on each tick that matches the time condition, pull the results, summarize, and then deliver it. In terms of the model configuration, web search plus summarization into 5 tight bullets is well within Haiku's capability. If you want synthesis across multiple sources or deeper analysis, you can set a different model for that specific task in the tasks block, or add an escalation directive in plain English, like use the premium model for this task. Since a lot of what you'll write in your heartbeat file involves time conditions, let me give you a practical reference over here. So for once per day at a specific time, write it as if it is between 8 a.m. and 8:30 a.m. and briefing not sent today. Key is always the guard. You want to use not sent today, otherwise you get repeats on every tick within the window. Or use the tasks block within a 24-hour interval and skip that guard entirely. Now every tick always. Just write the task with no time condition. So check pending tasks, there's no qualifier. The agent does this on every single tick, and so you only want to do this for tasks with the near 0 token cost. If it is a weekday morning, the agent's going to infer that from the system date. Now the thing to watch out for is time zone. The agent uses the system time zone of the machine running the gateway. If your server is on a UTC, which most cloud servers are, and you're in New York, there's a 5-hour difference. So 8 a.m. to a UTC server is 3 a.m. New York time. Now there's 2 things to handle here. First, you want to set active hours up time zone in your heartbeat config to your IANA time zone like America/New York. So the active hours window aligns with your local time. Second, be explicit in your heartbeat time conditions. Write at 8 a.m. Eastern time rather than just at 8 a.m. The agent understands time zone references and it's going to adjust. If you can, set your server's system time zone to match yours. That's the cleanest fix for both. Now, interval based within a day. Every 4 hours, check, etc. Whatever you want to check. But this requires your heartbeat every in your openclaw.json to be 4 hours or less. If your heartbeat runs hourly and you want to check every 4 hours, write it as a condition the agent can evaluate using the current time. Use the tasks block with interval 4 hours and let the gateway handle the scheduling. Now, here's what a real production quality heartbeat markdown file looks like when you combine everything. File comments at the top. So keep this file under 25 lines. It runs every tick. This is for you. It's a reminder every time you open it. Then the 3 task blocks. 1, if it's between 8 a.m. and 8:30 a.m. and morning briefing not sent today. Send a Telegram with the date, top 3 tasks, calendar events, and weather, and then mark it as sent. 2, if it's 7 p.m. and evening news not sent yet, search top AI and tech news from the past 24 hours, send a 5-bullet summary to Telegram and then mark it as sent. 3, check your memory for pending tasks due within the 2 hours. If any are found, alert by a Telegram with the task name and deadline. That's 3 distinct automations in around 14 lines. Morning briefing, evening news, and deadline alerts. Most ticks are going to be silent, and the agent's just going to read the file, evaluate each condition, and determine none of them apply right now. It's going to reply heartbeat okay, and then the gateway is just going to drop it. The token cost on a silent tick with light context and isolated session enabled is roughly 2,000 to 5,000 tokens on your cheap model. The active ticks once or twice a day are the only ones that are doing real work. Now let me break down the actual cost math so there are no surprises on your bill. A silent tick is when the agent reads the heartbeat markdown file, evaluates the conditions, finds nothing to do, replies heartbeat okay, and then the gateway is going to drop it. With the light context set to true and isolated session set to true, you're looking at 2,000 to 5,000 tokens per tick instead of 100,000. Those 2 flags are critical. Without them, the gateway is going to load your full workspace context on every tick. At 48 ticks a day on a 30-minute heartbeat with flag set, the baseline cost on a cheap model is super low, a few dollars a month at most. A briefing tick with web search, memory read, compose, and send costs you more because of the tool calls and longer output. But you're doing maybe 2 of these a day for your morning briefing and evening summary, still cheap on your Haiku or GPT-4o mini. A bad heartbeat file is where the bill blows up. So think long file, expensive tasks on every tick, wrong model. If you leave those light context and isolated session at their defaults of false, and then you set your heartbeat model to something expensive, and then you're also running unconditional web searches on every single tick, you're looking at $15 to $30 a month just on your heartbeat. That is literally the scenario the day 4 spending limits were there to catch. Now the rules are simple, right? Set your model to your cheap model in the heartbeat config, set light context isolated session to true, keep your heartbeat file under 25 lines, use time conditions and guard so most ticks are silent, set the target to your delivery channel, and check the dashboard's heartbeat tab after the first setup to verify it is behaving as expected. This is where day 5 and day 6 connect. So the heartbeat file tells your agent what to do. Your channels determine where the output goes. The 2 systems work together by design. Telegram is the default choice for heartbeat delivery. It has push notifications on mobile, which is fast and reliable. Most users set their target to Telegram in their config. In the heartbeat markdown file, you can also write send to Telegram in plain English, and the agent will route it accordingly. WhatsApp works identically, so you can set the target to WhatsApp or write send to WhatsApp in the file. Same push notification reliability on iOS and Android. You just use whichever app is your primary app. Then web chats can log everything, so even silent ticks appear in the heartbeat tab. In the dashboard at localhost 18789, this is the first place to check when you're debugging. You can see every tick, its status, and the agent's reasoning, whether it acted or stayed silent. Target key in your heartbeat config controls the default delivery channel. You set it to last, which means your last active external channel, or a specific channel name like Telegram, or none to suppress that delivery entirely. Remember that the default is none, so you must set this explicitly. You can also use the to field for a specific recipient, like a Telegram chat ID, or WhatsApp phone number in E164 format. So what do you do when something isn't working? Well, when something isn't working, this is the diagnostic path. First, you want to stop the dashboard at localhost 18789. You want to check the heartbeat tab. So every tick is logged with a timestamp, a status like silent or action taken or error, and the agent's reasoning. This gives you a full picture of what happened on each run. If you want to trigger a heartbeat manually without waiting for the timer, run openclaw system event --text, check for urgent follow-ups, -- mode now, and that's going to fire a heartbeat immediately with whatever text you provide. You can also use -- mode next heartbeat to queue something for the next scheduled tick. Now, common issues and fixes. If the briefing is repeating, it means you're missing the mark as sent guard. Add it and then add it or switch it to the tasks block with an interval so deduplication is automatic. If the agent's always silent, it means the time condition never matched. Check your server's time zone against where you actually are. Make sure the active hours.time zone is set correctly. If there's no ticks at all, it means that the every is set to 0 minutes in openclaw.json, or the gateway isn't running, or your heartbeat markdown file is potentially empty. All three of these cause a heartbeat to skip. Also check the dashboard for the skip reason, like empty heartbeat file, or no tasks due, or alerts disabled. Messages not arriving means the target is probably still at the default none, so set it to your channel. Or the channel isn't enabled. Another reason could be your number just isn't in the allow list. Tool errors mean the web search or shell tool isn't enabled in your agent's tool config, so just go ahead and enable it explicitly. 4 things before day 7. So write your first heartbeat markdown file, create the file at openclaw workspace heartbeat.markdown. At the minimum, a morning briefing with a time window condition and the mark is sent guard, plus a line reinforcing silence when nothing needs attention. Keep it under 20 lines. In your openclaw.json under agents, defaults, heartbeat, set every to 30 minutes, model to your cheap model, and target to Telegram or whichever channel you want delivery on. Set light context to true and isolated session to true. Second, you want to verify that first tick. So restart your gateway so the config changes take effect. Then either wait for the first tick to fire or trigger a new one with openclaw system event -- mode now. Check the dashboard's heartbeat tab to check what happened. And so at this point, assuming it's not 8 a.m., it should stay silent. The silence is correct behavior. And so you're just verifying that that loop's going to run, not that it fires the briefing. Third, you want to wake up to your first briefing. So let the heartbeat run overnight. Tomorrow morning, before you open up anything else, check Telegram. If the briefing is there, your autonomous agent is live. If it's not, you want to check the dashboard's heartbeat tab and debug from there. Fourth, you want to add one monitoring task. Once the morning briefing is working and you've confirmed it, add a second automation. So a task deadline check, an evening news summary, a disk space alert, it's your choice. Check the dashboard after the next tick to confirm that it evaluated correctly. Keep the total file under 25 lines. So that's day 6. At this point, your agent runs, it's optimized, it's reachable everywhere, and now it works on schedule. Day 7 is about identity. Right now, your agent is still a generic AI. It's capable and autonomous, but it doesn't have a personality, a voice, a set of values, or a way of thinking that's distinctly yours. The sole markdown file is the file that changes that. It defines who your agent is, how it communicates, what it prioritizes, what it knows about you, and your context by default. Day 7 is about identity. Sole markdown file is the file that gives your agent a personality, a voice, and a way of thinking that's distinctly yours. That's day 7. If you want hands-on help setting any of this up, I do consulting at otherarchhungle.com. And if this series is helping you, subscribe so you don't miss the next one. And I'll see you on day 7.